Welcome to the Explainer. I am so pumped you're tuning in today. Consider me your personal academic coach, and this session, well, this is our playbook. Today, we're getting you completely ready for your grade 7 assessment on ratios and proportions. We are going to build up that confidence, lock down those core concepts, and make sure you are totally prepared to just dominate this assessment. Let's get into it.
All right, here's the game plan for today's practice scrimmage. First, unit rates and proportions. Second, real-world percent applications. Third, a strategy session for test-taking decisions. Fourth, spotting the common distractor. And finally, a timed self-check.
Section 1. Unit rates and proportions, the blueprint. This right here is the absolute blueprint of 7th grade math. A proportional relationship simply means that one quantity is always a constant multiple of another. It relies entirely on having a constant multiplier. We call this the constant of proportionality, which, honestly, is just a fancy way of saying the unit rate. You know that equation y equals kx? Well, that k is your magic unit rate. If there's no constant multiplier, it is not proportional, period.
Think about it like this. Say you're buying notebooks for school. If you buy 4 notebooks, it costs you $6. If you buy 8 notebooks, it costs $12. To figure out if this is proportional, we just divide the y value, the cost, by the x value, the number of notebooks. 6 divided by 4, that's 1.5. 12 divided by 8, also 1.5. Because we hit that constant unit rate of $1.50 every single time, we've mathematically proven this is a truly proportional relationship.
Now, looking at a data table is one thing, but visual recognition on a graph is going to be huge on your assessment. For a graph to show a proportional relationship, two things absolutely must be true. First, it has to be a perfectly straight line, but a straight line alone isn't going to cut it. Second, it absolutely must pass exactly through the origin, 0, 0. I mean, if you buy 0 notebooks, it costs $0, right? Also, keep your eyes peeled for the coordinate point 1, r. Whatever the y value is when x is 1, bam, that is your unit rate.
So what happens when they throw harder numbers at you, like complex fractions? Test makers love giving you a ratio of 2 fractions and asking for the unit rate. Please, do not panic. It's just a standard division play. If a runner goes 1/2 mile in 1/4 of an hour, you just divide the distance by the time. 1/2 divided by 1/4 gives you exactly 2 miles per hour. Always remember, a fraction bar literally just means division.
Moving right along to Section 2, real-world percent applications, real-world tactics.
We're taking those proportional ratios and using them to tackle real-world money problems. This is stuff you're going to use for the rest of your life. So here's the golden rule for taxes, tips, markups, and discounts. You must always identify the whole or the starting base number first before doing any math. This is where like 90% of mistakes happen. If you don't accurately identify that starting amount, your percentage calculation is going to be totally off.
Let's run a textbook play right here. Say you find a cool shirt with an original price of $50. That $50 is our whole. Step 2, let's say our discount rate is 30%, which we write as the decimal 0.30. For step 3, we calculate the discount amount by multiplying the whole by the rate. 50 times 0.30 is $15. And finally, step 4, because it's a discount, we subtract that $15 from the original 50, leaving us with a final sale price of $35. Just take it step by step, keep it clean, and you'll nail it.
Section 3, strategy session, modeling test-taking decisions.
All right, we're going to do a little think aloud exercise to model exactly how a successful student processes a multi-step question under pressure. Here's a classic assessment question involving those complex fractions we touched on earlier. A runner completes 2 1/2 miles in 1/2 hour. What is their unit rate in miles per hour? Let's break down our test-taking strategy.
Let's just mentally step through the math together. First, I know I need miles per hour, so I set up my ratio. 2.5 miles divided by 1/2 hour. But working with a mixed number is messy, so step 2, I convert that 2.5 into an improper fraction, which is 5 halves. Now I've got 5 halves divided by 1/2. Step 3 is that crucial inverse operation. To divide by a fraction, we multiply by its reciprocal. So 5 halves times 2 over 1. Multiply across the top to get 10, across the bottom to get 2, and 10 divided by 2 is 5. Step 4, our answer is 5 miles per hour. Boom, handled.
Section 4, spotting the common distractor. Watch out for the trapdoor. Look, test makers absolutely love setting traps. They'll give you answers that look incredibly right if you make just one tiny mistake. It's our job to spot these distractors before we fall in. Check out this comparison. Over on the left, we've got a truly proportional relationship, y equals 4x.
It perfectly passes through the origin 0, 0. But look at the right side, y equals 2x plus 4. Imagine this is a taxi ride that charges $2 a mile, but has a $4 starting fee just to get in the car. Because of that plus 4, the graph crosses the y-axis at 4, not 0. Sure, it's a linear, straight line, but it is absolutely non-proportional. That starting fee ruins the whole thing. Do not fall for the straight line trap.
And here's another classic distractor. On the left, we see the right way to calculate a tip at a restaurant. You apply your 20% to the original meal cost of $40. On the right, that's the trapdoor. Calculating the 20% tip on the meal cost plus the tax. You always have to remember our golden rule from earlier. Identify the correct starting hole. You tip on the food, not the tax. And trust me, test makers will always have that incorrect higher number waiting for you in the multiple choice options.
Finally, Section 5. The timed self-check. The scrimmage.
Okay, take a deep breath. This is our rapid-fire, low-stakes scrimmage. I'm going to ask a question, and I want you to shout out the answer in your head, or out loud. I really won't judge. Let's go. Question 1. Is the equation y equals 2x plus 7 proportional? Why or why not? Think fast.
The answer is no way. That plus 7 at the end means the graph crosses the y-axis at 7, which means it completely misses the origin. Awesome job if you caught that trapdoor.
Next up, question 2. If 5 pounds of apples cost $8.75, what is the exact cost per pound? Find that unit rate.
The answer is $1.75 per pound. You literally just take the total cost, 8.75, and divide it by the 5 pounds. Money divided by items gives you the unit price every single time.
Question 3. I'm throwing a quick statistics curveball from your 7 SP standard in here to test your broader reasoning. Why might surveying only the basketball team about new school sports equipment be a biased sample?
Well, think about it. That sample totally overrepresents students who already care deeply about sports, completely failing to represent the general population of the school. Remember, good math and good data absolutely require an unbiased representative sample.
Wow, you absolutely crushed this playbook today. Remember, mastering proportional reasoning is literally one of the ultimate pillars of your grade 7 foundation. You are building the exact mental muscles you need to crush your pre-algebra journey.
Before we wrap up this explainer, I want to leave you with this to chew on. You've mastered ratios and percents here today, but how do you think you're going to use these exact same proportional tools to unlock scale drawings and similar figures in your upcoming geometry unit? Think about how a map scale works. That's right, it is all connected. Keep that curiosity alive, keep trusting the process, and hey, good luck on your assessment. You're going to do great.